Recorded live.
Good morning, good afternoon, or good evening, wherever you may be across the nation or around the world. Once again, you're listening to the VMware Communities Roundtable podcast. This is podcast number 622. My name is Eric Nilsson, and with me, I don't have a co-host. Today is Wednesday, September 14th, 2022. The weather here in California is beautiful. I do love the cool weather. We've gotten some cool weather. I know it's been up in the top 100s. It was 106, 100 to 8 2 weeks ago, but it has cooled off and we're now in the 70s. On the show today, we're going to be talking about spatial computing strategies and augmented reality with one of my favorite guests ever, Robert Scoble. Robert Scoble is a consultant and strategist. He spends his time around augmented reality, works with startups. He's a super cool guy to have. We've had him on the show before. So we'll get to Robert in a second, but before we do, Robert, I will do a little bit of the news. The news is VMworld Europe is coming up, and I'm excited to say that we're getting funded for Europe. We've got some good things coming. We've got the Nooks. We're going to be there with V-Experts, meeting the V-Experts, giving out Nooks. We will have code sessions. V Brown Bag's going to be there. Alistair Cook's got sponsorships. He's going to be there with his crew. We're going to be live streaming. We're going to have the community booth. We're going to have the blogger tables. I'm going to be doing some of the Nook sessions around sensors. The Nook session will end up in Schedule Builder. Schedule Builder is opening up, I think, at the end of the month. I don't know the exact date, but it is opening up at the end of the month because we're busy putting the schedules in for V Brown Bag and Alistair and some of the code sessions. So excited about that. It seems like we had such a good Explorer US, that Explore Europe is also going to be good. We're expecting a good turnout, as well as, we're doubling down on funding and making sure we got all the program there. So that should be good. You can register for Europe now. It's open. As I said, Schedule Builder will open up at the end of the month. So you'll be able to look at the sessions and the schedule yourself. The event is November 7th through the 10th. So looking forward for those 3 days to be there. We will be open Monday. So we do have the community booth. The show is Tuesday, Wednesday, Thursday. We're going to be there. We're going to be open on Monday, and we'll probably do some kind of sessions and engagements for community members that are around that day early. We're going to do some special stuff there, so look forward to that. We'll have the sticker exchange as always, and if you signed up to get your Nook, we'll have your Nooks available for you, and we're excited about everything that's going to be happening at that show. That's pretty much the news for what we got going on. So let's get to, as I said, one of my favorite guests ever, Robert Scoble. Robert, welcome back to the show. We always start with who are you and what's your career arc look like? How did you get here? Take a couple of minutes and take us through the elevator pitch.
I was fortunate enough to be born to a guy who got a PhD in material science and computer engineering and moved us to Silicon Valley in 1971. That's really why I'm here.
I know. Like, I had an interview.
My dad moved us to Cupertino before Apple started. And
I had an interview with a marketing person. She just graduated college. And I told her, marketing is just generic. Like, it's like PowerPoint. What you got to do is identify your passion. And then you have to identify where is your passion. What city does that come from? Like, if you're interested in, entertainment, Hollywood or New York, right? If you're in energy, go to Texas, right? Identify your passion. And if you're in Silicon Valley, and I said, I was lucky enough that, I came out of college, worked at IBM in Boca Raton, but I realized that all the cool tech is in California. No one told me the difference between LA and San Francisco. So I moved to LA first, and then I realized, no, I'm in the wrong city. Got to move again. Yeah. So, yeah.
And my passion is new things. My license plate is Neo Fan, right? If you see me in Silicon Valley driving my Tesla around, it'll say Neo Fan. Neo is new. I'm a fan of new, right? Plus, I'm a fan of Neo in the Matrix movie. So
there you go. I thought you just had ADD and you just had to bounce from one thing to the next thing.
I do have ADD. That's why my knowledge is not very deep. I mean, I can't compare to the geniuses who work at VMware deep in the technology, right? In the compilers and the virtual machines. I don't do that. I love people who do, and I interview them. I worked at Microsoft, and so I got to know a lot of people of that kind, engineers who are building this technology. And that's what's given me the insight to sort of predict the future now.
But what I would say that we
because I didn't predict the future. They're building it already. All I do is just listen to the engineers who tell you what they're building,
But it is a lot of hard work. Success, and somebody like you put in the hours, and you put in a lot of work, and you put in the focus. Right? Like, don't be confused and think that it's easy to be somebody like yourself, because even I look at you and I'm not you. I can never reach your level. I'm just a guy who works at.
I was going to community college in 1989. Right.
Wow. Yeah.
And I was walking through the parking lot and I saw a license plate Woz. And then I knew who that was. I was like, what is Woz doing at our community college? I was a journalism student at the community college, right? Really trying to be a computer scientist because my dad wanted me to be a computer scientist.
Right.
And so I was on that track at that time. And right after that, I switched. But, and Woz played a key role in why I switched, because I got up earlier and earlier every morning until I met him. I got there. Luckily, he's a very structured person. So he parks in the same parking space every morning at the same time. And so I just kept waking up until I got there before he did and introduced myself and said, I'm a journalist, student here. And I want to know why you're going here. Because it's weird.
Do you remember the answer?
Yeah, he was studying Spanish to teach his kids school. And so, he was taking a Spanish class.
That's awesome.
Because he wanted to teach his kids school. I mean, that's why it was weird, because it's like he could go to Stanford. He could get a free ride at Stanford.
Sure. Yeah.
Stanford would say, here's a fellowship for you. And pay him. Right? And
so you've been on many of the cutting edge, technologies as they develop. I know I've known you for years, and you were early in social media. You were adopting it as a communication mechanism. You spend a lot of time in various edge technologies. How long have you been looking at AI and spatial reality and this whole space?
AI was launched in my son's bedroom. Siri was the first AI app, and Siri was launched in my son's bedroom. I even slipped the entire field of AI by 6 months because I found bugs in Siri, and Siri slipped because of that visit to my son's bedroom. Seriously.
So
I had a famous video show back then. So they came and visited me six months before they launched.
Right, just to get your feedback and
to begin their press tour, right, as they were introducing the product to people.
Nice.
So I was the first one on the press tour, and I found a lot of bugs. Then they came and said, "Oh shit, we got to slip the press tour." Went back and fixed a few things, and then restarted the press tour. I think it was December of 2009, right? 10 years ago, 12 years ago. So and it was the first consumer AI app. Obviously, it had been built inside a government lab for 13 years. So AI as a theory or as a government technology was ahead of that. But nobody really understood that because that's classified and secret. Right. Siri was the first one to come out of that industry and become a consumer product.
So bring us up to the current space where, everybody's got GPUs, NVIDIA's got GPUs, everybody's building models, Tesla's, got models, they're collecting data, they're building data. So everybody kind of understands the self-driving and that space and some,
unless you have had your hand on a Tesla this week, you don't really understand what Tesla's doing. And if you haven't been in a Waymo or a cruise in San Francisco, you don't know what the industry is doing, right?
Right.
So where we're heading is a virtualization of everything. Or let's put it a different way, we're going to turn everything into a service. Because soon, I mean, sometime in the next decade, a lot of us are going to have autonomous cars. And a lot of us are going to have a robot that the autonomous car goes in and gets and brings home for some reason, like to deliver your pizza.
Right.
Right. And all of a sudden a robot is ringing your doorbell on your front door with a stack of pizza going, here's your pizza delivery. And you're like, whoa. And it's talking to you. Right. So now it's going to bring in a whole set of things and change into Western homes.
And so to kind of connect some dots for people who are listening to this, like what people don't understand about Elon Musk and Tesla and his other companies is that he's got a robot company as well, right? He's building a true AI, robot that's going to be your companion if you want him to be.
Right? We see it in a couple of weeks on the 30th at Tesla's AI Day, but Tesla's not alone.
Right.
Amazon, whoever gets the humanoid robot into the home first,
right,
wins and really dramatically changes the home.
Right.
Because now the reason you invited it in is because it promised it can do your dishes or do your laundry or set up your table or clean your bathrooms, something like that. There's some common things that people want a robot to do. Right. Tesla wants a robot to do the laundry because it'll save energy. And so that's why Tesla wants to get the robot in the home, because it'll make the garage machines more efficient and further the mission of pushing us to sustainable energy. But anyways, when we start thinking like this, right, like, oh shit, right? When you start talking to pioneers like Sebastian Thrun, who ran the Waymo company, or was the first guy who ran the Stanford autonomous car team that won the DARPA Grand Challenge, and then that became the Google effort, and then that got spun out as Waymo. Right. So you start understanding AI that way. It's evolving pretty quick, right? so you start thinking with all these pioneers, like what happens when a robot actually gets into the house, right? Or what happens when autonomous cars really start happening, like humanless driving really starts happening. And it's happening in certain cities, right? San Francisco and Phoenix, you can see cars without humans driving around, right? So it's coming.
Right.
Whether it's coming from Tesla or Waymo or GM's Cruise, I don't care. It's coming. And as soon as that comes to your curb, now it can bring services, right? Like
and that's to your point of
laundry, pizza.
Well,
sheetrock from Home Depot, even, right? Why don't you send your robot to Home Depot? If it's that good that it can talk to people and interact with people, shake their hands, even look at them like a human, and that's what the AI is learning to do right now. They're ingesting all the people on the streets. The self-driving car knows what humans look like already. When I'm not driving through children, it shows them as children on the screen.
Yeah, this just reminds me of Google Maps at the time. When Google Maps came out, we were all like, yeah, sure, right. That's never gonna, you're gonna never map every street in the whole planet, right? Like, hey, now that's just a given.
I have the first video of the Google car on YouTube. I was 6 months before New York Times wrote about the effort, right? I was driving next to it, shooting video of it, and I didn't think it was an autonomous car. I thought it was a mapping car because it had a LiDAR that was spinning on the top of it. And I figured it was mapping, which it is in truth, right? That's one of the tasks of this autonomous car, right?
Just now, like now, everybody knows that maps are just a thing. It's done.
It's not done.
It's a data collection effort that
maps are about to shift into 3D in a way that's going to blow people's minds.
Right. But what I'm saying is, at the beginning, no one really took it that seriously. It was like, oh, the geeky people are trying to map the streets, but then they map the streets, and everybody kind of, a year later, we're all like, oh, this is working. And I look at the rest of this space.
Bill Gates spent $1 billion doing that or so, right? Maybe even more. Right.
I think that in the next year or two, as they map the house, as they learn about my my existence and how I behave and everything about me. Just like I looked at maps, maybe it's my own personal thing. When I looked at maps, I went, oh, they're never going to be able to map every single street and every single sidewalk. But oh no, they did. They did it really quickly, right? Somebody put billions of dollars in, and next thing you know, it was. And I look at some of the rest of this, and I go, no, they're not going to actually be in my house and understand when there's a noise.
Yes, they will.
There and no,
yes, they will.
Right.
It works in labs. Yes, they will.
Right. Yeah.
And
then they'll be able to tell
the Apple headset's coming in 2023, right? And this thing has cameras on it and LiDARs that are seeing, and radios.
Right.
And radios. The radio network that it has in the house is a secret ingredient to make everything work properly. So, and this is why VMware is going to profit off of this move, because now I have a computer on every freaking inch of the world.
Yeah.
When I'm wearing this headset.
Right.
That means everything can be virtualized. Well, what's V? Right. Virtual. VM, virtual machine. What do you guys do? You make virtualization software for all the little screens that are going to be in our lives.
It also makes how we're using computers today kind of obsolete. Like I'm used to still having my back and my and staring at my screen. But
no, you're still going to have a 2D
computer.
10 years from now, you're still going to be able to pull up a 2D screen and do email if you want to do some email with people, right? Like old style.
But I still think that there's going to be a time when computing radically shifts, right? From today's, most people think computing is your laptop with a Zoom camera and away you go. And all of a sudden, computing will be much more pervasive in your house. Yeah. That's what you're getting at.
Even Zoom, when you get this Apple thing next year, even Zoom will still be 2D. Until Zoom comes out with Zoom 3D, and now you're a hologram on my kitchen table or something like that. Right. Hi there, by the way.
Right.
But even in 2D, I can make the screen way bigger so that you're really nice and big now, and it feels like I'm talking to you. And also the audio can be repositioned from there's no more physical speakers in the world. They're on your headphones, right? So it can blow people's mind even with 2D.
Yeah. And so the use of compute technology in the home, and then this gets back to compute capacity. Almost all of these things are using massive amounts of compute capacity in the cloud, right? Like your device. Right.
Now we're in a world, if you accept my premise that we're going to have some sort of device from Apple, at least the rich people will have it in 2023 and everybody else will get it in 2025, right? When it comes down in price, because it's probably $3,000 for this headset. The first one. The glasses that follow it are better for average people and are going to be cheaper. The people who make the glasses already tell me they can make a pair of glasses with a really nice monitor in them for less money than they can make the same thing on a phone product, because the phone screens are actually more expensive than the little projectors that they're putting into the glasses. They're cheaper to make, the little projectors.
Right, they're nearer to your face, so you don't need as much real estate.
No, it's you can use chips, you can use silicon, which is what our whole industry is based on, right? You can use silicon to do a new thing and make it really cheap. Silicon displays are really cheap. I mean, they're expensive today, but they're cheaper than my, $8,000 TV behind me, right?
Right.
So if you can get little chips next to your eyes, now you can do virtualization of everything around you. Everything is virtual, right? That's why I think VMware is well positioned with your deals with NVIDIA, because the developers now who are going to bring us things for this headset are going to be like mini golf developers or bowling developers or ping pong game developers, or are we going to take it on the factory floor? Training developers, right? For the factory floor, salespeople training, right? Walmart uses VR for training. It's just the cost of the device is a little pricey right now. Some of those things will happen in 5 or 10 years. Some of them will happen today. But the world is going to move, and it is already moving to 3D. And the NVIDIA world is all about 3D, right? Having a lot of GPU and AI compute in the cloud is going to matter. And it's all running VMware software to virtualize thousands of machines in the data center that are interconnected with fiber to do these new GPU-centric workloads, right? AI-centric workloads.
Right. You can see an explosion in cloud computing coming, as it is. And we've heard that from Raghu and others, and even the number of apps and devices that will be interacting with one another makes even like the Kubernetes architecture more relevant, because they're microservice scalable, because all this stuff, but then it has to be connected data to the backend data platforms.
Soon, by 2025, we're going to be walking through neural radiance fields. These are new 3D data structures that are around that you could walk through if you had an augmented reality glasses. If you had a phone, you can do that and see what this radiance field looks like, this 3D field. But it looks like the real world, right? So I have a tree in the backyard. If I want to build a neural radiance field of the tree, I take a photo while walking around the tree. So I get all the sides. I stick those photos into NVIDIA's neural radiance field generator, and out spits the AI hallucinates.
All right. So I got to know, what is a neural radiance field? What is
neural? I'm trying to explain it to you. Neural radiance fields takes the AI takes 2D photos from an iPhone, like
right. Okay, sure.
Picture,
makes data points of the whole thing.
Takes those 3 or 4 images together, and then tries to build a 3D scene of the room I'm in. Right. So think about shooting a birthday party. How many cameras come out for your first, let's say your child just turned 1 year old. How many cameras are shooting the kid in a birthday party?
Right.
Dozens in my family. Right. And so now if you could join a few of those photos together into the AI, ingest them into an AI that builds neural radiance fields, it exports them as a 3D scene. So now you're walking around your child's birthday party a year later, right?
Yeah,
in some sort of glasses or
some sort of glass environment where you can select.
This is why Apple's AI network that's in the house, this new ultra wideband network that's going to be turned on next year for the headset. That's why it's so important, because the AI computers are all around you already. Some are in your phone, some are going to be in the headset, some are going to be in the iMac, some are going to be in a laptop. Whatever's around you, it makes the whole network smarter, right? Because it joins if you bring a new Mac home, the whole network gets smarter, right? So the whole house gets better at doing these new 3D things.
Who's competing building these solutions? We obviously have Apple.
Nobody. That's the problem. I believe Apple's going to have a monopoly coming out of this next year. Okay. Now, how do you compete with it without having the network? That's the trick, because the headsets are using computer vision to see the world around you, right? And I have an Oculus Quest, Zuckerberg's Meta Quest.
Quest 2.
And that's how it sees the world. It has 4 cameras on the front of it that sees out. It's called inside out VR tracking, because it's looking at your real house and trying to make a 3D model of that house. And then it can figure out how to, make Beat Saber work in your headset, right? So where I was going with that is, that's a little bit, there's an error rate on that. If you're dancing and you're moving your head back and forth, everything's shifting around a little bit, right? If you add another factor onto that, like the network itself, the new network, the new mesh network that's coming out in 2023 has location on all the radios. So the whole set, I have 11 of these devices in my house, right? This iPhone has an ultra wideband chip in it. It's not being used yet, right? It has the technology in it, but it hasn't been turned on. It will be turned on next year. So this new mesh network, this ultra wideband network, has location that iPhone is broadcasting into the air from the radio wave, with the radio wave, the location of that iPhone in 3D. That's how it finds your keys underneath your couch, right? If you have a AirTag, here, I'll show you mine, right? If you have one of these AirTags from Apple,
right.
really,
Sure.
it's spitting the location into the air, right? Hey, I'm at XYZ. And then anything around it can go, oh, that's where the keys are, right?
Right.
The cool thing. IoT. This used to be science fiction, right? Just this key fob.
Yeah, that's that.
Now we have it now, and that, by the way, was developed not so you could find your keys, but to make the augmented reality better. Because if there's several of these little key fobs around your device, it can figure out the house in a new way, in addition to the way of using computer vision. So now you join both of them and it reduces error rates. And I call that Israeli thinking, because that's how they taught me to think like this in 3D when I visited several companies in Israel.
That does remind me that Tesla.
By the way, a lot of this is being done in Israel. Apple has thousands of employees in Tel Aviv, right?
Oh, that is interesting. I didn't know that. I wondered where the engineering was happening and how many.
Yeah, that's where this is happening. That's why I got to go there and visit all these R&D labs and autonomous drone companies and stuff like that. And I interviewed the founder of PrimeSense, what became the little 3D sensor in your iPhone, right? They got bought by Apple. So I understood what they were trying to build 10, 11, 12 years ago, these innovators. And we're still waiting for that. I mean, I was at Metaio in Germany, one of the first augmented reality companies, and they were showing me monsters on the sides of skyscrapers. We really don't yet have that in a good thing that I can say, go download it, right?
Right.
It's not yet quite here. It's close with Snapchat, right? But don't yet have it for everybody. Everybody's not aware that their phone can do this, right?
But then they're probably just going to use Apple's giant monopoly in the iPhone application space, right? And the Apple's App Store.
No, they're going to use the net. They have a monopoly just with the network, with the infrastructure underneath your new computing. That's enough to lock everybody out.
Right, but how are they going to get application developers in this space? I would assume just if you're an iPhone developer, if you're an App Store,
it's Apple. Every rich person in the world is going to want one of these or buy one of these.
Right. And so if you're an app,
so if every rich person has one of these, that's a market that a lot of people are going to be wanting to build for, right? So as soon as there's a developer SDK for this thing, any Apple thing, whether it's a phone or glasses, I don't care. It's a new AI network, really, is what you're building for.
Right. They'll just add it as another platform option in their developer package, and everybody that's there will continue to go there.
It'll work on your iPhone and your iPad too, right? Because I have a lot of AI computer in my iMac, right? But those don't. So, it could recognize in the future there's a lot of compute in the iMac. Let's use that.
I'm just wondering how NVIDIA and the guys that build the back end pieces actually connect to this ecosystem. If they have a monopoly, does Apple just go, forget it? We're going to just, no.
There is a gaming PC in the house with an NVIDIA card. A future NVIDIA PC, gaming PC, I would assume, for the kid, in the back room, would probably join this ultra wideband network at some point. I mean, does Apple want to be hit by antitrust in 5 years? They have to be careful not to abuse what they're about to build, their monopoly, right? They're about to have a monopoly on my home. There's not going to be competition. So they have to let NVIDIA join into the network. Otherwise, they're going to have antitrust issues.
Right, but I'm trying to tie it back to the AI.
Now the question is, do they need the NVIDIA card in the back? I'm not so sure that I already have two M1 chips, and 16.8% of that chip is just for neural network workloads that's not being used yet. is that enough to give an augmented reality user in the home a great experience? Probably. And this is where the cloud comes in. Let's say it's good enough for 80% of what people, or 90% of what people want to do, right? Seeing cool shit on the kitchen counter, watching movies, watching TV, listening to music, watching a concert. Live concerts are coming, live sporting events are coming, right? All sorts of fun stuff is coming for the headset. But if it can't do something like that, it requires too much AI, too much math to be done, and we can't. The network is smart enough to no, we can't do it locally. It could do it on the cloud. Varjo is a VR company in Northern Europe, and they built a really nice headset, a VR headset for enterprise users for training purposes and stuff. It's really sharp, and you can read screens. You can even code inside the headset. So that Volvo, for instance, is using it to test out all sorts of new interaction things inside the vehicle, right? Particularly as the world goes toward autonomous driving. So they need to think about how to design a vehicle for post-autonomous driving, and they're doing it in VR. But this company then said, "Oh, we need a lot of cloud. We need a lot of GP. We need a lot of little triangles to be built in front of your eyes, right? Because we have these big ass monitors, and nobody can keep up. The little Qualcomm GPUs in the headsets just aren't powerful enough. The ones in the phones aren't powerful enough to do really, really visually rich environments, right?" So now they built a cloud service so they can do that on the cloud and not need much AI locally in the house. So that's a place for NVIDIA to play. And that's what you guys are doing with VMware. And NVIDIA is building the data center interconnects and the virtualization software on top of thousands of NVIDIA cards so that developers can build stuff like this.
So it is interesting. I'll just throw this out here. You can give me your opinion. Like, it feels like we're going to enter into an iPhone moment, right? Like before the iPhone, we had phones, but it wasn't like this single internet device. Like Steve Jobs went up and said, I said a single internet device. What, really? Like, and he's like, yeah, no, it's it. And I feel like we're going to enter into a whole new paradigm, right? Whether it be glasses with your display, much the way Zoom, we came into a whole new paradigm for work. I feel like we're going to shift to a whole new paradigm where it's going to affect everything, the way you work, the way you interact, the way you visualize people, the way.
Let's not go too far the first year.
Right.
If you took a long-term view, yes, absolutely, it's going to radically change everything about human life.
Yeah,
right? If you take a decade-long approach or a 20-year approach. I mean,
and this is a question of how good the glasses are or the interfaces are, right?
All right. So I have an $8,000 TV behind me, right? That's an 83-inch Sony 4K OLED TV. I bought it so that I would have an idea of what a really nice TV looks like. The Israeli company Loomis Corporation brought waveguides. They build waveguides. They build the optics that are going to build the foundational element of the glasses that are coming, right? You got to put some sort of screen in front of your eyes to make augmented reality work. So they make that, right? And it's not quite as good as that on visual acuity yet, but it's getting pretty close. So they say they're coming back later this year with one that gets to be just as good as that, or close enough to argue about, right? Once you get that, then you can watch movies in the glasses. So boom, right? Once you're watching movies in the glasses, or seeing your emails or your whatever you want around you, plus you're able to play new kinds of augmented reality things both at work and at home, right? Oh man.
Yeah, I bought
because the factory owners, the bleeding edge factory owners are already starting to think about how do you augment everything for the worker so that the worker never makes mistakes, learns faster, gets up to speed faster, is safer, right? All that. So we're going to use this augmented technology at work as well. Maybe not in the first headset, but certainly over the next few years.
I bought a HoloLens a couple years ago from Microsoft back when they came out.
I have one too. Yeah.
Yeah. And yeah, I would say that if it wasn't so heavy, it would have been the way I would have worked. It was just a little bit too heavy on my head and my nose.
Optics weren't quite good enough either. They have to be as good as that TV. Once they get as good as that TV, you can open a code window up and start coding. Right. That's what you need to do to convert from using laptops or desktop computers or Dell monitors or whatever the fuck the hell you have in front of you. I mean, I've toured hundreds of companies, right, from film studios to sewage treatment plants, and everybody has the same thing in front of them: a Dell monitor or 2 or 5 if you're really a freaking fellow at Microsoft and you're really important, right? Now a few people have 5 because they did R&D, they did research actually on how more monitors around you affects your productivity. And it turns out just getting 2 monitors improves your productivity by about 10%.
Interesting.
Research knew that 15 years ago, right?
Yeah, it's going to be interesting to see. And I'm trying to figure out, like, my guess is it's just going to increase the amount of cloud data and the amount of cloud applications, the enterprise and the data centers and applications, and then security and all the things that we manage will just continue to explode because there's going to just be immense amount of data points, amount of data applications, interesting things that you can do. My guess
is infinite, man. Yeah, you can just walk around like a factory floor and think about what would you augment, how would you change each machine, and take a first principles approach to it, right?
And the other thing that
by the way, they're doing that in digital twins in labs. They're not even on the factory floor. They can walk around the factory floor in VR because it's all been digitized into a digital twin, right? And the same thing is going to be true in your house. Here's how the house is going to change. I was watching the WWDC, so Apple's developer conference, with the founder of Sync Reality, a little startup. After we watched that thing together, he scanned my living room, my family room, and then he ran a fashion show in my family room, and the models were walking on the floor. It knew, the AI figured out where the floor was and where the couch was and where the wall is and where the tables are, right? And so it can reconfigure itself like an autonomous car can, right? And figure out a path through your floor.
And have them walk around your sofa. And for people to listen to
the same problem as driving a car down the street is doing that, right? It's the same kind of thinking. It's like, how do I move a robot around this house, right? How do I move a robot around the street? Oh, it's the same thing. I hung out with Adrian Kaler, who built the first computer vision system on the Stanford autonomous car. And then he ran a good part. He ran core software for Magic Leap, which is an augmented reality glasses company that just won Best of Show at AWE this year. And he also ran a robot company. And he said they're all the same. They see the world the same way. The car sees the world as volumetric pixels. The drone sees the world as volumetric pixels. The robot sees the world as volumetric pixels. The virtual being that's coming is seeing the world as volumetric pixels. Well, that's NVIDIA's whole strategy right there, is one Hydra to connect them all with an AI.
Yeah.
Omniverse, right?
Yeah.
It's going to run your virtual being, your robot, your augmented reality glasses, your autonomous car, and whatever else we dream up.
Right. And it's interesting because when I think of Meta, I think of these virtual worlds that are just created as, simulated or just built virtual worlds that have properties that are built up. But I've never really thought about virtual worlds being the real world digitized to the point where you can then interact with the real world virtually.
Yes. And so can your robot.
Right.
Now you have to think about, oh, wait a second. My house has been completely digitized in a few years, right? Everything in the house is recognized. There's an app called Chooch that came out of Berkeley's AI lab that already on an iPhone recognizes 200,000 objects in the world. You aim it at a Chevy Volt, it says, oh, that's a Chevy Volt. You aim it at a Coke can, it says that's a Coke can. You aim it at keys, it says that's keys, right? It's crazy. So that kind of, so now you have to rethink search from scratch, right? I think that's also coming, right? You have new data because you have eye sensors, so the user is able to feed back to the system with their eyes and look at things and cause things to happen. Like you can look at a record label in a virtual record store soon, and it just starts playing Taylor Swift because you're holding a Taylor Swift album, and you're looking at it.
Right. There's been little bits of that so far. Like, you drive up the Golden Gate Bridge and there's apps that'll show you all the other photos that everybody's already taken from that geolocation. So there's little snippets of that already out there. Right.
But it's about to go next level.
Yeah, right.
Because we're about to go into a photorealistic 3D space called neural radiance fields. And those are going to be created by the AI. And there could be words in there, right? Telling you signs, go this way or something like that, right? But mostly you're going to be in like Yosemite National Park, in 3D and in your living room, right? From your living room. So, or a football game or a classroom, right? Or Taj Mahal, right? Or the ruins in Greece or a nice beach in Bali or, right? So all of a sudden you start thinking, oh, I'm going to want to go and see all these things, even if I've already seen them. Like I've been to the Taj Mahal. I know what it looks like.
See what it's like in the virtual reality.
Bingo. Because it's going to be badass in the neural radiance field. Plus you'll have a really expert scientist giving you a tour instead of the usual schlub. Right. I mean, I've had extraordinary scientists. Like here's one. When I go to Walt Disney World, I don't go like tourists. The CTO of Disney gave me a tour, and she had a stack of fast passes, and we hit four parks in one day, and she was explaining the science of the rides to me as we were having fun.
Right.
That's how you go to Disney.
Level of virtual experience you can get.
Everybody should have that experience of walking around with the CTO teaching you the science of the rides at minimum, right? In your Apple glasses as you're walking around the park. Everybody should have the same experience Robert Scoble had.
Right. And we look at today's YouTube and we're like, wow, everything is there. There's a YouTube channel for everything. You can fix anything. You can, DIY because I can go learn how to be a gene editor. There's YouTube videos for everything. But imagine that. But in the reality of applying that to virtual spaces.
In VR, there's an app called Nano. And when COVID started out, I got invited to learn about this virus in VR. So I was in VR and they blew the virus. You could grab the virus and make it as big as a house. And when you make it that big, Nanome shows you the chemical structure of the thing. Like there's an oxygen molecule, there's a carbon. Right? And you can see how it all works, how it all fits together, how it's all interconnected. And you can click on it with your finger and change it. Like change that oxygen to a carbon. Let's see what happens.
Run a simulation on that. There was on HoloLens something like that. They did a very basic CRISPR demo where you could do some CRISPR and they would show you the RNA.
But on this side and this side of me, I had scientists who were also teaching who were teaching me about this. And I like, look at this thing over here. This is how it works, how it attaches to the human body, right? That's interesting to us. Can we figure out how to fuck with that and disrupt it with our drug or our vaccine, right? I'm like, wow, if I had this tool in my college days, I might have passed chemistry. Right? Maybe. It was hard to learn chemistry. You had to learn all these equations and you had to think about what it was doing in the soup, right? A mole of this and a mole of this. And what does that mean inside the bucket? I don't know.
You did hit on an interesting concept too, which is what do we need to learn versus what do I just dial up somebody that can tell me, oh, here's the structure of this chemical. And you go, yeah, all right. I don't have to really learn that because anytime I need it, I can just tell my glasses to show me how that worked again. Right.
Well, or you can learn fast to do a new task. That's what AR is going to do. It's going to be much faster at educating you than before. So now you start thinking about disruption to education. Oh, wait. What is the magic of going to Stanford? Why do you spend $70,000 so your kid goes to Stanford for a year, right? other than you're proud that he got in, right? Or she got in.
It is the filter to get in, sure, right?
Right, it's hard to get in. Only one kid from my high school class got in, right? I didn't.
Right.
In fact, MC Hammer and I were teaching the class there, and we were joking they would never let us in.
No.
And now we're teaching a class together here.
Right. You can teach easier than you can get into Stanford, but that's okay.
Anyway, so what's the magic of going to Stanford? If you walk around the medical school there with a tour guide, they take you into places like Mr. Hands Labs. There's a professor there that just does prosthetic hands. That's all he does. That's what he's done for 40, 50 years. And he's written so many things on it and got awards and blah, 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 blah. He's the best in the business at hands. And he has a whole classroom of hands, like all sorts of mechanical different hands, like hundreds of them all around the walls. And that's the magic, is you get access to that and you get access to him. Now I can make it so you get access to both in augmented reality at some level, right?
Right.
And now I can also show you how to do chemistry or material science or electrical engineering in a whole new way in the glasses. And so I can make you a better engineer and faster and make you learn faster. And so now you're getting out of a engineering degree, at Stanford that takes 4 years. Now you can maybe do it in 2.
Right. Yeah.
Particularly if you're smart. If you're dumb, all right, 3. Right. But it'll help you study because it'll show you how it works in, like, material science is now being done at atomic level, right? How do you see that with the human eye? You can't. You have to have a machine see it. And so now the machine can show you what the lattice looks like of, the atoms you're laying down.
So if we are running up to the top of the hour, but if I had to pin you down, because this is the 25-cent question, what's the timeline look like? What's your best guess at when this stuff's going to start showing up?
January. On the 16th anniversary of the iPhone, Apple's going to announce the headset, is the expectation in the marketplace as of today. What day is this?
Yeah, right. Sometime in September. So 6 months is a long way away. Right.
This guy Quo, who's the top analyst in the industry, followed me. I said January, and then a week later he said January. So he is the one everybody listens to because he's the best analyst in the business. And if he says January, it sets the expectation for the whole marketplace. So if it's not January, somebody's going to leak something real big from Tim Cook saying, "Oh shit, we just slipped," right? We have to see you in March, or we'll see you in June next year. We're going to slip into Thanksgiving or something like that, right? Or right. If something even worse than that is going on, right? Like I didn't predict COVID was coming when COVID came, right? So shit can go down in the world. Okay, he has to get on and reset expectations of what's really going to go on, right? Otherwise, there's going to be worse and worse consequences over time. Plus, he has multiple companies working on this.
Right. It's a lot of money for a lot of people.
Disney's working on it. Dolby's working on it. Car companies are working on this strategy, right? There's a lot of moving pieces to this thing. That's why it keeps slipping. It's already slipped a few years. It's like it's hard to do.
And this is kind of like, this will probably be the big first major technology shift since Jobs been out of the strategy, right? That would be my guess.
No. This is Steve Jobs' last product.
Oh, all right.
I tried to get Bill Gates to give me $300 million so I could go buy Web 2 companies back in the day, right? Mm. And he turned me down. I had lunch with Mike Arrington. He started TechCrunch, and we both sort of pitching him ideas, and he said, "No, we're not going to do that." And I wrote him a letter and saying, "Go and buy all these Web 2." I was sitting next to Tim O'Reilly at the first Google advertising conference while he was writing the Web 2 post. So he was talking to me about like what Web 2 is and who the movers and shakers would be, and I was already a blogger, so. Matt Mullenweg, who built Automatic, I knew him when he was 17 years old, and he worked at CNET, right? And so I knew he was interesting because I liked Automatic. I was a first user of a lot of things back then, right? So I write to Bill and I write to the executive team, and they turned me down. So if I get turned down with a good idea, by the way, not listening to me cost them many tens of billions of dollars so far. Right. I mean, they could have owned Automatic. That's 19% of the web right there. Right. Right. So
you think January, February announcement available sometime, probably usually within a quarter or so. They'll make their stuff available when they announce it. So sometime a headset will start to get to.
No, it's like the iPhone. It's going to copy the iPhone pattern that the iPhone laid down, which is January you announce it, June you ship it. We're going to have a party in Cupertino at the main store, at the main headquarters, the Oval Building one.
Mm-hmm. Yeah.
And so anybody can come and just hang out with us. Because the line, I was the first one to buy an iPhone at Steve Jobs' store, right? Mm-hmm. And standing in line for 36 hours was more fun than actually getting the product.
Well, has anybody seen the headset? Is it a big, like?
Oh, yeah, several of my friends have. How big there's some mock-ups that sort of show a little bit what it looks like. Yeah, it looks like
about the size of a Quest, like the Facebook one.
It's something big that goes over your eyes.
Okay.
It's a pass-through device. It's not meant so you go mountain biking with it on.
Okay, so it is a pass-through. It's not a
pair of glasses.
Right,
the first device is not a pair of glasses. The glasses come in waves. There's many glasses that they're working on, right?
No, but the headset will be a pass-through, but it's a headset, not glasses, but a headset. Pass through, so it's augmented, not full virtual, and maybe
hold on. Technically, you're only seeing pixels on screen on chips.
Oh, really?
You're not seeing the real world at all. If the chips turn off, you're in darkness, right?
Okay.
You can't see nothing.
All right.
So because you're only seeing virtual, I say technically that's virtual reality.
Yes.
But no one will call it that because Apple won't call it that, right? Apple will call it like Apple reality or something, or some sort of new name, right? And the way it looks to the human being wearing it is you are seeing what you think is the real world around you, like your table, your floor, your carpet, your walls, your wife running around right over here, right? If you're wearing the headset, you're going to see all that, just like you see on a Tesla. If you ever get a ride in a Tesla car with full self-driving and watch it work, it makes a 2D representation of the real world, so that you can see how it's seeing the real world, right? The glasses are going to do the same, or the headset are going to do the same thing, and the glasses will too. That it'll know that's a chair and be able to do things with it. Right.
Yeah. Interesting. Fun times. I'm excited about it. I'm excited to see.
It's going to be a big year. I mean, Tesla also is bringing Tesla and Apple are bringing products that I think human beings are going to talk about 100 years from now. They're really important products.
Nice.
So it's going to be a big year for the tech industry and good for VMware because you're going to build the virtualization underneath everything, right?
Well, we'll certainly be in the data center for many, many years to come, and it's going to explode. So here's to you. Before you go, we post this stuff on YouTube. Our YouTube channel is V Barbecue, VBARBECUE. Yeah. I always ask the guests, you're in California, you must get some barbecue. What's your favorite?
No, you got to leave California if you want barbecue.
You're gonna go. You're not down in Santa Maria, down in California.
No, you got to go to Texas, or you got to go.
Our barbecue is Happy Barbecue in California.
Pappy's in Kansas, not Kansas City. St. Louis was my favorite in America when we did our barbecue tour. We took a little barbecue tour around America, 9,000-mile tour, right? And I've done, Tony Shea, who started Zappos, took me to barbecue in Austin. I worked for Rackspace, which is a Texas company, so I got the religion, right?
I've done the. I've been.
There's a good place in Oakland, though. If you're in the San Francisco Bay Area and you can't go to Texas for your barbecue,
right?
There's a place in Oakland. Now that you're asking me, I'm gonna.
That's all right.
Yeah,
that's okay. We're good. But really, it's a question: what type of barbecue do you like? Also,
I like all barbecue.
Right.
I'm not, you put a piece of meat in front of me with something on it, I'm eating it, The place in Oakland is called Everett and Jones, and you have to go to the one in Berkeley. That's
Berkeley, Everett, and Jones.
Yeah, the Berkeley one's better than the Oakland one. But yeah, it's
all right.
I meet people from all over California there, so I know that particular place has a good following across California.
I'm putting on my reading list here, or my bucket list. Berkeley, and you said it was.
I'll tell you a barbecue story. Tony Shea took me to this place in Lockhart, Texas, and the secret there, the experience there, is the oven. So the oven is in the middle of the restaurant.
Okay.
And it's a wood-fired oven where the fire is outside the oven. And most of the smoke and heat gets pulled into the oven by a big-ass fan on the ceiling that sucks the air in. So it sucks the oven through the meat, it's a big oven. It's like I think they could put like 300 ribs on there. Right. It's a sizable thing. And so some of the smoke and fire escape into the restaurant and doesn't get sucked into the pipe that goes into the oven. And so and it's been there for like 70 years. Everything is black. Like everything in the restaurant has a little bit of black soot
on it. Yep. Mm-hmm.
And you come out of there and they have a mountain of mesquite wood in the back. Like my partner and I took pictures at the wood pile out back. It's a thing. You got to go there. It's like going to the Mecca, You come out smelling like mesquite and you're just having a good time because you're in real barbecue. Your barbecue as an experience.
Nice. All right. Well, Robert Scoble, thanks a lot for coming. Spending an hour with us. Didn't have to pay you anything, which is awesome. I love it when you come as a friend and come to the show. And
you're paying. I got some honey coming, right?
That's right. You're on.
My wife works at VMware. She puts me to work.
Yeah, she does. She does on occasion. It's great to have you here. Everett and Jones Barbecue is at 1955 San Pablo Avenue, Berkeley, California. You got to give that one a shout out and go there and have some barbecue. And it is lunchtime here in California. Robert Scoble, thanks for being here. I'm sure we'll get you. We're going to have you come back in June of next year, and we'll see whether that headset showed up.
Well, will we be on a 2D screen together?
Yeah,
no, we're going to be playing table tennis together.
We will make that happen. Awesome. Thanks, guys. We'll see you again next week. Tony Foster, shout out as well. Thanks for being here. And I hope your haircut goes well. Be back, go get some barbecue, and see you next week.